Let us understand how to sketch reciprocal of linear function quickly. Question is, sketch reciprocal of following linear functions. One is 3x minus 2y equals to 6 and the other one is y equals to 2 minus 3x. So let's start with 3x minus 2y equals to 6. It's a line. So to sketch this line, we need to find x and y intercepts. That's the best way of sketching this line. So for x-intercept, we can do y equals to 0 and find x, right? So if y equals to 0, then x will be 6 divided by 3, which is 2. And to find y-intercept, we can make x equals to 0 and find y. So if x equals to 0, then we have y equals to 6 divided by minus 2, which is minus 3. So these are your two intercepts, right? So the points are here 2 and 0, and the other point is 0 and minus 3. 2 and 0, 1, 2. That's the first point, which is the x-intercept. 0 and minus 3, second point, which is the y-intercept. Now if we join them, we get a line. So that is how we can sketch a line quickly using x and y-intercept if we are given line in kind of standard form, right? Now it's just to join them, and once we join them, we get a straight line. Now after drawing this straight line, we are going to draw a reciprocal of this straight line. So that's the line. Reciprocal of this function means y equals to, now reciprocal of this will be, let us say f of x is a reciprocal of this function. So to find the reciprocal, we have to find first what y is and then find the reciprocal of the function, right? So from here we can write y is equals to, we'll rearrange this equation and then we can find what reciprocal of the function is. But what we can do is, instead of even doing that, we can straight away do reciprocal from the line itself. That is what I'll teach you from this particular example. Now when you have a line here, what is the reciprocal of 0? At this point, which is 2, the value of the function is 0. So what is the reciprocal of 0? It is undefined. So we get a vertical asymptote at this point, right? Let me draw a vertical asymptote here. Now, what is the reciprocal of 1? Reciprocal of 1 is 1. This is minus 1. So reciprocal of minus 1 is 1, minus 1. So it's an invariant point. So we'll just mark them here. Similarly, that point is also invariant point. These 2 points are invariant since reciprocal of plus and minus 1 is plus and minus 1 respectively. Now as the function increases to infinity, its reciprocal is going to decrease to infinity. If the function is positive, reciprocal is positive. That gives us the end behavior. That is, if x approaches infinity, y will approach 0, that too from negative side. On the other hand, if x approaches negative infinity, we see that the function approaches negative infinity too. And reciprocal of negative infinity is 0, but from the negative side. So we have the end behavior. How about the behavior near the vertical asymptotes? If we are approaching 2 from the right side, we are on the positive half. So we will be approaching positive infinity. If we approach 2 from the left side, the function is negative. So its reciprocal will be negative infinity, approaching negative infinity. That gives us key points which help to sketch the reciprocal. Now we can join from the invariant point towards the behavior near the infinity and towards the asymptote and get our function. So that function is the reciprocal of the function, right? So that is reciprocal function. So that is how you can get reciprocal function. Now here this is our vertical asymptote at x equals to 1, 2. Right? So that is how you can quickly sketch reciprocal of a function. This is minus 3, then we have minus 1 plus 1. Let us do this exercise once again and try to understand how to sketch reciprocal of a function from the given graph of line. So this time the function is written in slope-intercept form. Y equals to 2 minus 3x. What is the y-intercept? Y-intercept is 2, right? So let's go to the point 2. And what is the slope? Slope is minus 3. So in this we know slope m equals to minus 3 and b, the y-intercept, is 2. So start with y-intercept 2. Slope is minus 3. That means we can go down 3 units. 1, 2, 3 and 1 right and get more points. 1, 2, 3, 1 right, like that. You can also go up 1, 2, 3 and left, right? So that way is getting more points. Joining them gives us a straight line which represents the given equation y equals to 2 minus 3x. Now we have to draw a reciprocal of this line. We know reciprocal of 0 is what? Infinity. So we have a vertical asymptote here. So we can just sketch a vertical asymptote at this point, which is like this, right? Then let us observe the behavior near the vertical asymptote this time. As we are approaching vertical asymptote point from negative side, the function is positive. Since the function is positive, we will approach infinity but in the positive direction. So that is the behavior. On the other hand, when we are approaching vertical asymptote from the right side, that is the positive side, the function is negative. So the reciprocal will approach negative infinity. So that's the behavior near the vertical asymptote. As far as the horizontal asymptote is concerned, as x increases, y value decreases towards infinity, and therefore the function will approach 0 from the negative side. So that is how it will behave near positive infinity. How about as x approaches negative infinity? The function is positive, so it will approach 0 but from the positive side, right? So these are critical points. Now we can also write this function as, let us say, f of x as 1 over y, right? 1 over y, which is 1 over 2 minus 3x. If x is 0, then the value is 1 over 2, which is half. So at x equals to 0, the value of the function is half, right? So it is going to cut y-axis at half. So that is the y-intercept. Now we can join these points and draw the reciprocal. Also important point is invariant. So that is the invariant point where x is minus 1. And for this function, it is x is plus 1. So plus 1, minus 1, the y values. Y-intercept. And the end behavior helps us to draw a fairly accurate graph of the reciprocal function. So we can continue in the same fashion on this side and join our reciprocal function. So that becomes the reciprocal function, right? You can see in both the graphs that if the function is increasing, then the reciprocal is decreasing. Do you see? In all its domain. In this graph also, the function is decreasing. So, the reciprocal has to increase. It is increasing. That confirms that the behavior of the function is perfectly fine. And we also can figure out from here the domain and range of the function. Right? Now, to find the domain, it is important to note that domain here is x belongs to real numbers, where x is not equal to 2. And in this case, the domain is that the denominator cannot be 0. That is, x cannot be equal to 3 over 2. So here, the domain is x belongs to real numbers, but x is not equal to 2 over 3. We will find it from the equation itself. Equating denominator to 0, that is 2 minus 3x equals to 0. That gives us x is equals to 2 over 3. So that is how we can find the equation of vertical asymptotes, which is x equals to 2 over 3. That is our vertical asymptote. Right? So that is how we can actually graph reciprocal of a linear function quickly without doing much calculations. I hope you appreciate it. Thank you.